scientists in the field of physics worldwide were filled with great anticipation upon the commencement of operations of the highly advanced high-energy particle collider. After a prolonged period of waiting, spanning several decades, these experts were eager to witness the revolutionary impact of this remarkable invention on our comprehension and awareness of the universe. The Large Hadron Collider, constructed by the European Organization for Nuclear Research, commenced operations in September 2008 following a protracted construction period. The machine's inventors spent several years refining the collider, which has since facilitated the resolution of several enigmas of the universe in various runs. Recently, CERN scientists disclosed that they detected an unexpected occurrence when they activated the Large Hadron Collider with a new maximum beam of energy. Since this event, they have been attempting to hypothesize the precise cause, but they have only formulated theories that are yet to be substantiated. The largest and most energetic particle collider was constructed by CERN in collaboration with over 10,000 scientists, hundreds of universities, and laboratories from more than 100 countries between 1998 and 2008. The collider is situated in a tunnel with a circumference of 27 kilometers, approximately 175 meters beneath the France-Switzerland border near Geneva. In 2010, the first collision in this hadron collider was achieved at an energy of 3.5 tera-electron volts per beam, which is nearly 4 times the previous world record. Following upgrades, the collider reached 6.5 tera-electron volts per beam. The collider is comprised of 4 crossing points where accelerated particles collide. 7 detectors are strategically positioned around these points to detect various phenomena. While the Large Hadron Collider primarily collides proton beams, it is also capable of accelerating beams of heavy ions, such as lead-lead and proton-lead collisions, which are typically conducted for 1 month annually. The primary objective of this collider is to enable physicists to test the predictions of different particle physics theories, with a particular focus on measuring the properties of the Higgs boson and searching for the extensive family of new particles predicted by supersymmetric theories. The term hadron pertains to subatomic particles that are composite in nature, comprising of quarks that are bound together by the strong force. This phenomenon can be likened to the way in which atoms and molecules are held together by the electromagnetic force. The hadrons that are widely recognized are comprised of baryons, such as protons and neutrons, as well as mesons, such as the pion and kaon. These particles were initially detected during cosmic ray experiments conducted in the late 1940s and early 1950s. A collider refers to a type of particle accelerator that facilitates the collision of 2 opposing particle beams, resulting in the interaction of the particles. The construction of colliders may pose a challenge, however, in the realm of particle physics, they serve as highly effective research instruments due to their ability to attain a significantly higher center of mass energy compared to fixed target setups. The analysis of collision byproducts enables scientists to gather evidence and insights into the subatomic world structure and the governing laws of nature. Several of these byproducts are exclusively generated through high-energy collisions and undergo rapid decay. Consequently, it is unfeasible to examine them through alternative means. The collider is situated within a circular tunnel, which is located underground at varying depths between 50 and 175 meters. This variation in depth was a deliberate decision aimed at minimizing the amount of tunnel that would be situated beneath the Jura Mountains, thereby avoiding the need for excavation of a vertical access shaft. The selection of this particular tunnel was motivated by the desire to avoid the high costs associated with purchasing expensive land on the surface, which would also have had an impact on the landscape. Additionally, the Earth's crust provides shielding against background radiation, which is an added benefit. The tunnel itself is 3.8 meters wide and is lined with concrete. Construction of the tunnel took place between 1983 and 1988. The tunnel in question was formerly utilized as a facility to accommodate the sizable electron-positron collider. It spans across the boundary separating Switzerland and France at 4 points. The majority of the structure is situated within the borders of France. However, the edifice's upper portion accommodates supplementary apparatus such as compressors, ventilation machinery, control electronics, and refrigeration facilities. The annual estimation for the amount of data generated by the Large Hadron Collider, LHC, and its associated simulations is approximately 15 petabytes. The computing grid was constructed as an integral component of the Large Hadron Collider, LHC, with the purpose of effectively managing the extensive quantities of data generated from its collisions. The project in question is a collaborative effort on an international scale, characterized by a computer network infrastructure that is grid-based. The construction of the Large Hadron Collider incurred a cost of approximately 7.5 billion euros, rendering it one of the most costly scientific instruments to have been developed. The construction of the project was authorized in 1995, with a total budget allocation of 2.6 billion, and an additional 210 million designated for experiments.
Following its launch on September 10, 2008, the initial testing phase was conducted.
The Large Hadron Collider, LHC, experienced a delay of 14 months due to a magnet quench incident that resulted in significant damage to over 50 superconducting magnets, their mountings, and the vacuum pipe. In the initial operational period spanning from 2010 to 2013, the Large Hadron Collider, LHC, conducted particle collisions by directing two opposing beams of either protons with a maximum energy of 4 tera-electron-volts or lead nuclei. The initial findings of the Large Hadron Collider, LHC, encompassed the detection of the Higgs boson, various composite particles such as the Botonium state, and the inaugural production of quark-gluon plasma. The primary objective of the Large Hadron Collider's research was to explore the potential presence of the Higgs boson, which is an essential component of the standard model of physics, as predicted by theoretical frameworks. However, due to its high mass and elusive characteristics, it had not been observed before. The scientists at CERN hypothesized that if the standard model was accurate, the LHC would generate multiple Higgs bosons per minute, enabling physicists to validate or refute the existence of the Higgs boson.